Hey, it's Mr. Allred, and we've been working with rational functions and working on graphing them. We really haven't graphed one yet, but that's what we're going to do here. So just to kind of summarize how we got to where we are when we pick up here. Number one, we've looked at domain issues and categorized them as vertical asymptotes, and there can be more than one vertical asymptote. Okay. Then we looked at the degrees in the numerator and denominator to figure out if there was a horizontal or an oblique asymptote. And there cannot be more than one horizontal or oblique asymptote combined. That means you can't have both a horizontal and an oblique. You have to have one or the other or neither. Okay, and then we need to actually kind of make our graph. So that's what we're going to focus on here. So the first one we're going to deal with is the function 3x squared plus 2 all over x squared minus 5x minus 6. And we've already figured out that we have vertical asymptotes at -1 and 6 and horizontal asymptotes at 3, and those are on the graph. So what we know is our graph is going to be broken basically into 3 different sections. There's going to be a section to the left of -1 that does not connect to the middle part. The middle part will run from -1 to 6, and there'll be a section to the right of 6 that does not connect. So we're going to have 3 disjoint pieces here. Okay? So we got to figure out how they're behaving. One thing we know is that this the horizontal asymptote, our graph is going to flatten out as it goes toward the ends. So we're going to get close to that as we move away. But the question on that left and right hand side is, does it come to that horizontal asymptote from the top or bottom? So probably the best thing to do is just kind of come along and pick a couple of points. I'm going to use my calculator. I want something to the left of -1, so I'm going to use -2. Okay, and I also want something to the right of 6, so I'm going to use 7. At the same time, I need to know what's happening in the middle here, and just by example, I could be going up on either one of these vertical asymptotes or down, or a combination. So I'm going to pick something close to each vertical asymptote in between. So I'm going to pick 0, and I'm going to pick 5. And I'm going to plug all these into a calculator, and because it takes a little bit of care, I'm going to pause the video, punch everything in. You can do the same, and then we can compare our answers. Okay, I've got my points here, and I'm going to run through them and kind of stick them on my graph a little bit, or at least in an area that will help me understand what's going on. I've got -2 to go to 1.75, so that point is right about here. I think it's obvious that this thing must get close to that vertical asymptote from the bottom. There's something not so obvious there, but we'll touch it in a moment. When I plug in 7, I get 18 something. So over here at 7, I'm way up here. So that kind of tells me that my graph has to be getting close to that horizontal asymptote from the top and be going straight up over here. In the middle, 0 gives me -1/3, and 5 gives me -12, which is somewhere down here. So I believe my graph is going down on both sides. Now the thing that is not so intuitive on this graph is what's happening to the left of -1, and you could mess this up very easily, and that would be okay as long as you follow the science here. But putting everything in, let's see here. It dips down, and it's okay to cross a horizontal asymptote. That's not too much of a problem. But what we've got is everything kind of going in a certain direction. The only thing I think you could mess up here by picking these points is it kind of leads you to believe that this left-hand side is going to go down. But I've got the actual graph over here. And if you mess them up, it's not too bad if you find the right characteristics. But here, let's just kind of take this guy and put him right beside the graph we made. And we'll delete them in a moment, but this is kind of what we got. They don't always do exactly what you expect, but you can see the two breaks in the graph for the vertical asymptotes, and this is really blown up a whole lot, but the horizontal asymptote would be right there around 3, I guess. So that's what this graph looks like. Okay. So let me get rid of it, and let's go to the next. And like I said, if you get the right characteristics, sometimes you can still mess up the graph because you would need a whole lot of detail in some of them. But let's see this one here. This one here is also broken into 3 parts. So let's kind of take a chance and see what happens as well. So we're going to pick something to the left of -6, so maybe -7. Okay, and the function, I'm sorry, was 5x plus 2 over x squared minus 36. And then we need something to the right of 6, which might be a +7, and then something close to -5, -4, and then something close to, excuse me, I'll take something close to -6, so let me use -5. And then something close to 6, so I'll use +5. So I'm going to once again pause and plug all these numbers in my calculator and see what I come up with and try and complete the graph. So I'll see you in a minute. Okay, so going with the points that I found here, at -7 I found that to be about -2.5. So that would put me somewhere down here, which leads me to believe my graph is going to be on the bottom side. At +7 I got 2.8, which is about up here, which leads me to believe my graph will be on the top side. Then in the middle here, might take a little bit of extra planning, but at -5 I got about 2.1, which leads me to believe my graph is going to hug toward positive infinity at that asymptote. And the other one, 5, gave me -2.5. which leads me to believe it's going to hug negative infinity going toward the 6 asymptote. And I don't know the exact points in here, but it looks like my graph will probably do something like this to connect those. So if we get the right directions, we're okay. Even if we make a couple mistakes, as I keep saying, it's alright. But let's see what the actual graph, here it is. Let's bring it over and compare. It's possible to make some mistakes here, but the graph is kind of zoomed in a little bit differently, but we see the general shape here. We see the horizontal asymptote at the y = 0, and we see the 2 breaks that appear to be right here around 6 and -6. Okay. So we did good there. I'm having trouble figuring out why it won't delete here. Oh, gone now. Okay. So let's go to the next one. Okay, so this one is f of x equals x cubed plus 3x minus 4 all over x minus 5. We had vertical asymptotes at x equals 5. We didn't have a horizontal asymptote. We didn't revisit this for the oblique asymptote, but we did figure out that, or we can look at it and see that the degree of the numerator is 3 and the degree of the denominator is 1. So that's why it gave us no horizontal asymptote, but that is more than 1 difference in a degree, so no oblique asymptote. So I didn't discuss it, but we said we can't have both a horizontal and an oblique, but we never really said we don't have to have either, which is the case here. So we don't have a lot to go on. We just got this break over here where x equals 5, so we got 2 things happening. So we have a good chance of making a mess of this, but let's see here. Let's pick something a little bit less than 5, so maybe 4. And let's pick something a little bit bigger than 5, so maybe 6. And I'm going to put those in the calculator, so I'm going to pause it again and see where we end up. Okay, so as an example, gave you some pretty crazy points here. So what I calculated here was at 4, I have -72. So over here on the left side of the asymptote, I feel like I'm going down. Definitely can't reach -72. And on the right hand side, I have the point 6,230, which definitely tells me I'm probably going up over here. Now, I'm sure that when I show you what this looks like, you're going to be, how would I ever get that? And I quite understand that. But let's see a couple things here. We don't have a horizontal asymptote, so we're not going to go flat anywhere. So our graph is either going to keep going up, or it's going to turn around and go down some way, but it's never going to go flat. And the same thing on the other side. So you would have to pick quite a few points to really get a good behavior here. So this would not be a good example to put on a test or anything. But let me show you what the graph looks like, because you're not going to expect it. It's this guy. So let's bring him over and compare it to what we got and show that we've at least caught the characteristics that are here. They're not so easy to see. But right here in the middle, we have the, I don't know why that none is there. It's coming through it. But right here in the middle, around what's supposed to be x equals 5, you kind of see that break where the graph is going down on the side like we said, and then when you jump over, it's going up on the other. And so you don't see this thing going flat anywhere horizontally, so that definitely shows you the lack of horizontal asymptote. And it doesn't really get even in the same direction as you keep going out. So just completing the graph, even though I don't think you would have much luck with this, it kind of keeps going up and kind of turns around and goes around here, but these points are very far off. As you can see, it went way up here to turn around, and it's very extreme. But you can obviously see from the graph and the characteristics we got, we're not showing those horizontal or oblique asymptotes there. Okay, so let's get rid of this guy and move on to the next. So our last one here is 3x squared plus 2x minus 4, and that's all over x plus 2. We had a vertical asymptote at x minus 2. We did not have a horizontal asymptote, but we had an oblique asymptote at y equals 3x minus 4. So more or less, we've got a graph to the left of -2 and a graph to the right of -2. And in both cases, it has to get close to the oblique asymptote and the vertical asymptote. Now, that could do this graph, if you can follow along, it could kind of come across here as that thing's going to turn. And it could come across here on the other side. I'm not saying that's what's going to happen. We could take this off, take this off. We could have something that comes through the middle here, and we could have something that goes through the middle down here that I didn't leave room for. But it's got to hug both the vertical and the oblique. So let's pick a couple points and see what happens. So we need something to the left of -2. So let's just do -3. And something to the right of -2, so -1. And once again, I'm going to pause to save some time. You punch them in the calculator, see what you get, and we'll come back. Alright, so we're back, and we got our 2 points. Trying to fit them in the graph here. They don't go very well, but let's see here. -3 went to -37, so over here was -3 to the left of -2, and it's way down yonder. So as these two things cross, it's going to kind of open up, and we're going to see it go to the inside. You'll see it better when I pull the graph over in a second. So both of these fell off the graph paper. That's not a good thing, but it does happen. Here, the other point, -1, -3. -1, -3 is actually something we can figure out, but it needs to be trapped between these two. So on this side, it's going to come up here, and it's also going to turn around and follow this over here. So it should be following along the slanted line and grabbing a hold of it. So let's see. We're going to pull the graph, put it right next to it so you can compare. And you can see how I would have a, don't waste too much time here, a oblique asymptote through here, as well as the vertical asymptote through here, and it kind of gets trapped between those two. So that graph works out really nice as long as you have room to put it in. So hopefully we'll get numbers that fit better on the graph.